Welcome to everyone. In this first semester, we have a maths paper, Matrices and Calculus. The subject code is MA3151. The subject consists of 5 units. The first unit name is Matrices. And we have the following topics in first unit. The first topic is eigenvalues and eigenvectors of a real matrix. Second topic, characteristic equation. Third topic, properties of eigenvalues and eigenvectors. Fourth one, Cayley-Hamilton theorem. Fifth one, diagonalization of matrices by orthogonal transformation. Sixth one, reduction of a quadratic form to canonical form by orthogonal transformation. Seventh topic is nature of quadratic forms. Eighth one, applications. Under this topic, we have one application, stretching of an elastic membrane. So in first unit, totally there are 8 topics. So in which we have important one, eigenvalues and eigenvectors of a real matrix. This topic is the basic of the big question topic, diagonalization of matrices by orthogonal transformation and reduction of a quadratic form to canonical form by orthogonal transformation. The course outcome of first unit is how to use matrix algebra methods for solving practical problems. This is the introduction part for matrix. Since we have studied in our lower class what is matrix, how to identify, how to write one matrix. The matrix is nothing but the rectangular array of a numbers. The numbers or functions are called the elements. The numbers are called what? They exist in the matrix is called what? Elements. Then order of the matrix. The order of the matrix is very simple. Just count the number of rows and the number of columns exist in the matrix. Then we will get order of the matrix. The order always denoted by m by n. The notation, how to read it? M by n. M represent number of rows, n represent number of columns. For example, consider this matrix in which how many rows we have? There are 3 rows and 3 columns. So that it is nothing but 3 by 3. The order of this matrix is what? 3 by 3 matrix. Next we are going to define characteristic equation. The definition of characteristic equation is determinant of a minus lambda I. It is nothing but characteristic polynomial. The polynomial, after using this formula, we will get one polynomial of degree either 2 or 3. It depends on the matrix. A is 2 by 2 matrix. The characteristic polynomial will be quadratic polynomial. If it is 3 by 3 matrix, the characteristic polynomial will be cubic polynomial. So if you have one square matrix A, then we can get characteristic polynomial by using this formula. This is usually called as determinant of A minus lambda I. Then if the determinant is equal to 0, then the characteristic polynomial becomes a characteristic equation. So the characteristic equation formula, determinant of A minus lambda I equal to 0. Then the characteristic roots. After getting characteristic equation, we can find the characteristic roots or eigenvalues. Usually the characteristic roots are called eigenvalues. We will discuss in the next slide about eigenvalues and eigenvectors. So the characteristic root means the equation will be solved. After solving the equation, we will have some answer for lambda. That answer are called what? Characteristic roots of matrix. This is first problem under characteristic equation. Find the characteristic equation of A equal to, it is 3 by 3 matrix. For this, we are going to find the characteristic equation. Already we discussed that the characteristic equation represented by one formula, determinant of A minus lambda I equal to 0. So, or you can use the general thing which consists of three unknowns D1, D2, D3. So, if you are taking this formula, automatically it is equivalent to this one lambda cube, because the matrix A is 3 by 3 matrix. So, you have to start with lambda power 3 minus D1 lambda square. First term plus, then next term minus. Plus minus alternatively will come. Then third term will be plus because second term is minus. So third term will be D2 lambda. You have to reduce the power of the lambda also. First term lambda cube, second term lambda square, third term lambda power 1, last term lambda power 0. So that the characteristic equation will be lambda cube minus D1 lambda square plus D2 lambda minus D3 equal to 0. So we are going to find the unknowns D1, D2, D3 by using the following formulas. D1 is nothing but the trace of the matrix A. Trace of A is nothing but the sum of the diagonal elements exist in the given matrix. D2 formula, sum of the minus of the major diagonal elements. Since we have 9 elements in the matrix, for each and every element we can calculate minor. The formula consists of the minus of the major diagonal elements. Diagonal, how many elements in diagonals? There are 3. So for these 3 diagonal elements, try to find minus, then you have to add it. So that we will get the coefficient D2. Then D3 formula, determinant of A. We all know how to take determinant. So after using this formula, D1 becomes 3. D1 is nothing but sum of the diagonal 1 plus 1 plus 1. So it will be equal to 3. Then D2. D2 formula, sum of the minor of the diagonal. So first minor of the diagonal, this is the first diagonal. So the minor of this one is the determinant of the remaining term. You have to omit the first row and first column because the first diagonal exists in first row and first column. After omitting the rows and column, then for the remaining data, you have to take determinant. So determinant is nothing but the cross multiplication. 1 into 1, 1. Then minus of plus 1. So 1 minus 1, 0. Then it is the first minor plus second minor of second diagonal is 1, 3, 1, 1. Determinant of 1, 3, 1, 1. Then take the determinant 1 minus 3. You will have minus 2. Then third minor of third diagonal element, this one. So we are going to omit third row and third column, so that remaining data you have to consider. For that you have to take determinant. For this one we will get the answer 1 minus 0. So finally 1. So after simplification of all these things, you will get D2 as minus 1. Then D3. D3 formula is the determinant of A. Determinant of A, already we all know how to find determinant of A. In your lower classes, you have studied determinant of A. Just you have to follow the formula as you have studied in your lower class. Determinant of A depends on the first row of the matrix. Consider the first row, first element plus, second element minus, third element plus. So first consider this element plus 1 into determinant of these 4 values. So 1 minus 1. Then minus 0. 0 into anything is 0. So minor of this one you have to multiply. Then automatically everything will be 0. Plus 3 into its minor is 2, 1, 1 minus 1. Determinant of 2, 1, 1 minus 1. So take the determinant minus 2 and minus 1, minus 3. So after simplification, the answer becomes minus 9. After getting the answer of D1, D2, D3, just substitute all these things in the general characteristic equation. General characteristic equation consists of 3 coefficients D1, D2 and D3, in which you have to substitute all these things. So that finally you will get lambda cube Then D1 answer is plus 3. So minus 3 lambda square. Then D2 answer minus 1. Already it is plus. So plus into minus 1. It becomes minus. So minus lambda. Then D3 answer is minus 9. One more minus exists in the formula. So minus into minus plus. So plus 9 equal to 0. This is our required characteristic equation of the given matrix A.